So these next ones I have as labeled solving complicated. Now they're not like, the questions themselves don't look that much more complicated. However, the difficult part about this is that there is no logarithm that can be a 7 and a 2. There's no logarithm that work for 2 and a 6. All the, like here, 3, 4, 5. There's nothing. The other ones all had nice logarithms, like 27 and 81. Those could both be log base 3. 16 and 32, those could both be log base 2. And so there were nice logarithm bases we could choose. Here we can't. So because we can't, it's a little bit easier in that you don't have to choose anything, but the math is going to end up becoming a little bit more difficult. So we just do log base 10. Now you don't have to. There's a lot of universities that will choose to use the natural log to solve. Maybe because ln has 2 letters and log is 3 letters. I don't know why. But the reason we do logs, again, is so that we can bring these exponents down and turn them to multiply. So that doesn't change things. That's kind of the whole point. So then I got just a log base 10 of 7, or just a log 7. And this is just a log 2. Again, base 10, but we don't really care. And this is the part that becomes tricky. So I'm going to write this 2x times log 7. You can't do anything with it. It just becomes a 2x log 7. So the numbers and letters go out in front, and then the log comes at the end. Now when you multiply this in x times log 2, well, you can't join them together. Sorry, you can't join them together, so it just becomes an x log of 2. And 3 log 2, again, you can't put them together. They just become a 3 log of 2. So the logs kind of just get tacked on the end, and then whatever the x is in front, the 3 is in front, the 2x is in front. Now, this is the challenging part. You need to get the x's on one side, so I'm going to move this whole chunk, this whole term, over to this side. So I've got a 2x log 7 minus an x log 2. And then this side is just the 3 log 2. So see, already we're writing all these logarithms. It's just, there's no nice way to write that. Now this is what's interesting here. Because you get the x's alone, you can say, well, these both have an excess in common. So I can factor an x out, and I'm left with a 2 log 7. And if I factor an x out here, it's just a minus log 2. And on the right is just a 3 log 2. So this is and this is just a number. We can put this in our calculator if we wanted to. So you can go 2, well, I can turn my calculator on, apparently. 2 log of 7 minus log of 2. I mean, that's just almost 1.4. So this is just 1.4. So this could say 1.4x, in which case you just divide both sides by 1.4. But we're not going to divide both sides by 1.4. We're going to divide both sides by just this exact value. And that's gone. So x equals all of that. And there's a ton of writing in all of this. Now I should tell you as well that if your final answer is backwards, meaning if the top is negative and these ones are kind of flipped, where this is negative and this is positive, that's okay. So if everything is the opposite symbol, then you're okay. That's the exact same answer. Okay, so that's the question if you want to write it down, but then again, they're already written in the notes. So let's try another one here. 2 and 6, there's nothing that'll work, so I'm just going to do a log of both sides. So 2 to the negative x and 6 to the x minus 2. So I can bring that negative x down, and I can bring the x minus 2 down. So this is a log of 2 and a log of 6. So the x minus 2 comes down, just the log of 6. Negative x comes down, just the log of 2. So these I can just join together to be a negative x log 2. It's not really much I can do. And in here, I can multiply this in. So I get, again, nothing can be combined. It's just an x log 6 minus 2 log 6. So I want to bring the x's together, so I'm actually going to bring this one over to the other side. So I'll subtract it away onto there. Again, these can't be combined. So I'm just going to write a negative x log of 2 and a negative x, I don't know why I wrote 1x, it's true I guess, but of 6. And on the right side I just have a negative 2 log of 6. And then once you have your x on the same side, this question is identical to the previous one in terms of the steps. You can just take out I was going to take out a negative, but no, I'm going to just take out a positive x. And I'm left with a negative log 2 and a negative log 6. Again, that is just a number. And I don't know what the number is. We could put it in a calculator, but I don't really care. I'll just divide it over. So I'll divide that whole thing over onto this side. Negative log 2 minus log of 6. And I could rewrite it, x equals all of this, but that is, I'm just too lazy. So that is our answer. And I've written in the notes, if everything is a change symbol, so if this is a positive, this is a positive, this is a positive, if that's what your answer is, and when you add things, it can be in different orders, so the log 6 could be here and the log 2 could be here if you wanted. But if all the symbols are flipped or opposite, that is the exact same answer. So A and B are, I consider that, relatively quite difficult compared to what we've done, but C is the most challenging one. And the reason it's most challenging is just because it's got a times in here. And because it has a times, it means that when we take the logarithm, we're going to have to split it up to an add. So 4 times 3 to the x minus 1 and 5 to the x. So because this is a times, I can split it up into 2 logarithms that are being added. And that's the tricky part. So this is just a log 4. I can't do anything with that, but these ones have exponents I can bring down. So this is just a log 4 plus there's this x minus 1 times log, well, I don't know why I wrote base 4 there. It's just a log of 3. I'll just rewrite that again. Log of 3. And bring that x down, and there's a log of 5. I don't know why I put brackets around that. So the x come down, so log 5 times x. The x minus 1 comes down, times that by the log 3, and this was just by itself. So this log 4 is just a log 4. However, this can be multiplied in. It needs to be FOILed in or expanded in, or however you want to word that. So there's going to be an x log 3 and a negative 1 log 3, which I'm just going to write as negative log 3. You don't need the 1 in front. And on this side, it's just going to be an x log of 5. So you want to get the x's together, so I'll probably move this one over here, because this log 4 and log 3 can be together on the left. So I'll just minus this x log 3 over onto this side. So I've got a log of 4 minus a log of 3 on the left, and on the right I have an x log 5 minus an x log 3. So there's already a ton of work that's gone in here. So to recap, I logged both sides. Then I took this, because it was the times, and I split it up. So this log 4 and this log 3 to the x minus 1. That's all I did. Then this x minus 1 can come down to a multiply, and this x could come down to a multiply. And this just becomes an x log 5. This log 4 is just there, but this has to be multiplied in. So I've got an x log 3 and a negative 1 log 3. Now I've brought that x over to the left. I got to bring the whole thing. So now both of these have an x in them. You can factor that out. and you're left with a log of 5. I guess minus, if that x is gone, you're just left with a log of 3. And on the left, you have log of 4 minus log of 3. And again, this is just a number. I don't know what it is. And so I'll just divide it away to get the x alone. Onto this side, log of 5 minus log of 3. And I could go x equals all of this again, but it's too much work. I will just leave it like that. Log 4 minus log 3, log 5 minus log 3. So again, if this is a negative and this is a positive, this is a negative, this is a positive. If you do that, that is the exact same answer. So that's it for this. We've got 2 questions to try after that get us to solve for a specific letter, and it will require us to use logarithms. And then after that, I think we're done this solving chapter.